Okay. Section 6.9 deals with business and technology. This is another um, section where we're applying uh, the concept of percents. And here this can be used in the business field and technology fields as well. Okay. And in business, we deal with individual or employees' paychecks. Here we're going to be looking at hourly rate. Now, the federal law requires that employees working for an hourly rate must receive overtime pay when they work more than 40 hours in a week. Any overtime hours are paid time and a half. What that means is that they are paid 50% more than their base hourly salary. So in this case here, let's say that Daryl received $8.32 per hour. If he is paid time and a half, what is his increased hourly rate for working more than 40 hours per week? So here we're going to take 50% or 0.50 and multiply that by his rate of $8.32, which will give us $4.16, and then add that to the $8.32, which would give us $12.48. So in this case, he'll be making $12.48 per hour over the 40-hour limit. And here's some application that deals with the hourly rate. Let's say that Steve distributes beverages to gas stations. He is paid $12 per delivery. If he makes more than 10 deliveries per day, his rate increases by 35%. On Monday, he made 17 deliveries. How much did he earn before deductions? Okay, so here, he made 17 deliveries. So he's over the 10 deliveries that he made per day, so he's going to get an increase of 35%. Okay, so the extra deliveries, he made 17 deliveries. We're going to subtract that from minus the 10 deliveries, which is going to be that limit, and that's going to be equal 7. So he made 7 extra deliveries. Now let's find out what the amount of his increase is going to be. He's going to get 35% of $12 per delivery, so it'll be 0.35 as a decimal times the $12. He'll get $4.20. So that means his increased rate will be the $12 plus the $4.20, which would give him $16.20. So for those 7 deliveries, he will get $16.20. So the amount of the paycheck will be the $12 times the 10 plus $16.20 times the 7 extra deliveries. Now 12 times 10, that's 120. $16.20 times 7 is $113.40. And if we add that to the $120, he'll get a paycheck of $233.40. And so that's how we calculate the person's paycheck. Okay, let's look at a comparison here. Bill works at a furniture factory producing chairs. Last week he worked 45 hours and made 46 chairs. 2 ways of pay are available. He could either get a $14 per hour pay with a time and a half increase, or $15 per chair with a 25% increase beyond 30 chairs per week. Which method of compensation would be better for him? And let's look at these two. Let's look at part A, the $14 per hour with a time and a half increase. Now he's only going to get, now he worked 45 hours last week, so here's the amount of his increase. That's $14 times 0.5, which is a 50% increase. That's going to be $7. So he'll get $7 extra per hour along with the $14. So his overtime rate will be $21 per hour over the 40-hour week. And then his overtime hours, he worked 5 hours overtime, so he'll be paid $21 times the $5, as you can see here. And then we'll add to it the $14 per hour for the regular 40-hour week. So if you multiply $14 times 40 hours, that would give you the $560. $21 times 5 hours overtime is $105. Add that to the 560, you'll get $665. So his paycheck will be $665 if he took the traditional $14 per hour with a time and a half increase. Now, option B is the $15 per chair with a $25% increase beyond those 30 chairs per week. So let's look at how many extra chairs he made. He made 46 chairs, okay, and the limit is 30. So 30 from 46 is 16. So he made 16 extra chairs. Now let's look at the amount of the increase. He's going to get a 25% increase, so it'll be 15 times 0.25, which will be $3.75. And if you add the $3.75 to the $15, you'll get $18.75. That's the increase rate. So he'll be paid $18.75 for each of the 16 chairs that he made. So his paycheck looks like this. $15 times the 30 chairs, and we're going to add to it $18.75 times the 16 chairs. Well, $15 times the $30 is $450. $18.75 per extra chair times those 16 extra chairs he made will be $300. So add $450 and $300, you'll get $750. So with this method, he'll be paid $750. Now, if you want to compare those two, you'll see that method B is better because he's getting a 25% increase for each extra chair that he makes over 30. Okay, next thing we're going to look at is commission. In this case, salespeople usually receive a commission which is calculated as a percent of the amount of goods or services a salesperson sells. The commission is earned on top of the base salary. So let's say we want to find the amount of the commission here. A car dealer sold a Ford Mustang for $17,256. If his commission rate is 5.3%, find his commission. So we just simply multiply the commission rate of 5.3%, as a decimal would be 0.053, multiply that by the cost of the Ford Mustang, which is $17,256, and you'll end up with a commission of $914.57. So that would be the amount of the car dealer's commission. Okay, another example would be Michael sold furniture for $37,903. If he is entitled for 7.3% commission on all sales over $12,000, what would be his commission? In this case, for him to get a commission, his sales must exceed $12,000. Here, it has exceeded $12,000. It's $37,903. So we're going to multiply that by 7.3% or 0.0713. And when we multiply that, you'll get $2,766.92. That's the amount of the commission that Michael will receive for selling the furniture. All right, another example dealing with commission is this. Samuel's base salary is $1,450 per month, plus a 6.25% commission on all sales over $5,000. Last month, he sold electronics for $32,800. Find his monthly gross paycheck. Okay, so now he's going to get $1,450 as a base salary. We're going to add to it 6.25% or 0.0625 times the amount of the electronics that he sold, which was $32,800. and the sales was over 5,000, so he is entitled to that commission. So 6.0625 times $32,800 will give you the $2,050. We'll add that to the base salary of $1,450 to get $3,500. So his gross paycheck will be $3,500. All right, we're going to compare two things. Here, Mr. Samsung works as a car dealer. Last week he sold cars for $56,000. Two ways of compensation are available: $400 per week plus a 2.2% commission, or just a 3.1% commission. Which method of compensation would be better for him? All right, now let's take a look at the first one, the $400 per week at a 2.2% commission. Okay, $400 plus 2.2% would be 0.022 times the sales of $56,000. We'll do the multiplication for first. 0.022 times 56,000 will be $1,232. Add that to the $400, he'll get $1,632. So with that first option, he will get a paycheck of $1,632. The second option is just simply a 3.1% commission, which is just simply 0.031 when you change 3.1% to a decimal times the 56,000, and you'll get $1,736. So in this case here, you'll see that method B is much better. Well, by only $100. All right, next we'll look at the markup and finding the final price. Here, markup is the difference between the price a store pays for the merchandise, which is a wholesale price, and the price it sells for to its customers, and that's called the retail price. Now, stores usually mark up a price as a means to cover their expenses and to generate profit, and the markup is defined as a percent of the wholesale price. So if we look at this example here, let's say the cost of a set of furniture is $4,300. Find its retail price if the percent of markup in the furniture department is 130%. And as you can see in this particular problem, the markup is $4,300. We multiply that by 1.30. Keep in mind 130% as a decimal. We drop the percent sign, we move it 2 places to the right, so the decimal point is between the 1 and the 3. So 4,300 times 1.30 would give us $5,590. That's the markup. Now, we need to find out what the retail price is. We'll take the markup, the amount of the markup, which is $5,590, add that to the retail price of $4,300, and you'll end up with a retail price of $9,890. All right. Now, let's suppose we want to find the percent of markup. There are some cases where a retailer sets the exact selling price first, and then they determine the percent of markup. Like in this example here. Let's say a dealership buys a Toyota Camry cars for $15,600 and sells them for $20,890. What is the percent of that markup? So here we're looking at the percent of increase, which is going to be the higher value minus the lower value, and that's going to be divided by the original price. So here the higher value was $20,890. We're going to subtract from it the lower price of $15,600, and that's divided by the lower price, or the original price, of $15,600. When you subtract $15,600 from the $20,890, you'll get $5,290. Divide that by the original price of $15,600, you'll get, to 3 decimal places, 0.339. Now, we change 0.339 to a decimal, to a percent, which will be 33.9%. So the percent of markup will be 33.9%. All right, next we'll look at production. For factory managers, it is very important to determine the dollar distribution of production expenses per unit produced. Okay, and in this example, this is going to be quite easy. Let's say an assembly plant sells cars to dealerships at $12,450 each. This price is made up in the following way. Components is 13%, labor 36%, facilities 14%, tariff 4%, profit 33%. Find a dollar amount for each expense per car. And here's how we will do that particular problem. We'll take each one of those percentages, change them to a decimal, and multiply them by $12,450 each time. Like for components, it'll be 0.13, which is 13%, times $12,450. You'll get $1,618.50. That's the cost for the components. For labor, 36% or 0.36 times $12,450. That would give you $4,482. Facilities is 14%. That's going to be 0.14 times $12,450. That would give you $1,743. For tariff, it'll be 0.04 times $12,450, which would give you $498. And finally, for profit, 0.33 or 33% multiplied by $12,450 will give you $4,108.50. All right, next is finding the tolerance. When making machinery parts, even very experienced workers make small deviations from the required dimensions. However, these deviations must have definite margins which determine both maximum and minimum dimensions that are acceptable. If these margins are overstepped, a part is considered by quality control to be defective and unusable. That is why on all blueprints, specifications for parts dimensions are given with a tolerance showing the allowed error. The tolerance is usually given in percents of a part of dimensions. Okay, so here, usually with deviations here, we're going to be using plus or minus in this case because we want to find the minimum deviation and the maximum. Like in this problem here. The technical drawing of a part lists its height as 34.12 inches with a tolerance of plus or minus 0.14%. Find the margin of dimensions for this part to be usable. So here we're going to find out what the allowed deviation is. So if we give or take 14.14%, well, 0.14% as a decimal will be 0.0014. We're going to multiply that by 34.12 to two decimal places. It will be 0.05. So the allowed deviation would be 0.05. So it'll be 0.05 below the 34.12 and 0.05 above 34.12. So when we find the minimum height, we're going to subtract that deviation, which is 0.05 from the 34.12 to get 34.07. And the maximum will be 34.12 added to the deviation of 0.05 to get 34.17. So here, these two numbers represent the lowest and the highest dimensions for that part to be usable. It can't be no less than 34.07 inches, and it can't be no more than 34.17 inches. All right, next is energy efficiency. Due to friction and heating, only a part of an engine's horsepower is used to move a car or a truck, and that part is called the effective horsepower. That is why the effective horsepower is always less than the engine's horsepower. To find the efficiency of a car, it is necessary to determine what percent of the engine's horsepower is the effective horsepower. And an example of just that would be, well, here's a few. Let's say a car has a 145 horsepower engine. If 34% of this power is lost in the transmission, how many horsepowers are lost? Well, that's simply taking the 34%, which will be 0.34, multiply that by the horsepower in that engine of 145, and you'll see that you'll have a 49.3 horsepower loss in the engine. Well, lost in the transmission. Another example would be this. The engine of a truck produces 256 horsepower. If 17% of this horsepower is lost in the transmission, how many horsepower are delivered to the wheels? Okay. Well, first, find out. Then we know that 17% of this horsepower is lost in the transmission, so that's 0.17 as a decimal. Multiply that by 256 horsepower in the engine. That means there is a 43.52 loss in the horsepower in that engine. So to find the horsepower delivered to the wheels, we'll subtract the 43.52 from the 256 horsepower total to get 212.48 horsepower. So the amount of horsepower delivered to the wheels will be 212.48 horsepower. All right, let's look at this example. A car has a 185 horsepower engine. The car's specifications list that 23% of its power is lost in the transmission and 13% is lost in the wheel bearings. Find the efficiency of the car. All right, let's look at the first loss, which is the transmission. And that's 23%. So that's going to be 0.23 times 185, which is 42.55. So 42.55 horsepower is lost in the engine. In the transmission. So that means our intermediate horsepower will subtract that 42.55 from the 185 to get 142.45 horsepower. And then we'll look at the second loss. That's the loss in the wheel bearings, which is 13%. So it'll be 0.13 times 142.45, which will be 18.52. Now let's subtract that 18.52 from the 142.45. That would give us 123.93 horsepower. That represents the effective horsepower. So 123.93 horsepower is your effective horsepower. Now to find the efficiency of the car, we take the effective horsepower and divide that by the original horsepower. Our effective horsepower, we found that out to be 123.93. We'll divide that by the original horsepower of 185 to get 0.6699. Now, as a percent, we move the decimal point 2 places to the right. It will be 66.99%. So the efficiency of that car is 66.99%. And also we'll look at chemical solutions here. It is a mixture of a chemical substance and water or other solvent. Every solution is characterized by a definite percent of pure chemical substance contained in it. Like in this particular example here. A chemical reaction requires 46 milliliters of alcohol. If 60% of alcohol solution is available, how many milliliters of a solution are needed. Okay, so here, the amount of the alcohol solution will be your amount of the pure alcohol divided by the percent of the alcohol solution. And that will help us determine the amount of the alcohol solution that we need. Okay, so here, 46 milliliters of alcohol. That's your 46 because that's pure alcohol here. And then the percent of alcohol solution, that's 60% as a decimal, will be 0.60. So when you do 46 divided by 0.60, that'll be 76.67 milliliters of an alcohol solution that you will need. And then finally, directions state that 0.4 gallons of varnish are needed to cover 1 square foot of cabinet surface. How many gallons of 80% varnish solution should be used to cover 50 square feet of cabinet surface? So here we're going to find out the amount of the varnish solution, which is the amount of the pure varnish divided by the percent of the varnish solution. The amount of pure varnish was 0.4. So it'll be 0.4 divided by 80% varnish solution, which will be 0.80 as a decimal. So 0.4 divided by 0.80 will be 0.5. So the amount of varnish solution that we're going to need is 0.5 gallons, or half a gallon of varnish solution. But we want to cover 50 square feet of cabinet surface. So in this case here, for 50 square feet, the total solution would be 50 times half a gallon, which will be 25 gallons. So here you're going to need 25 gallons to cover 50 square feet of cabinet surface. Right. That will conclude section 6.9.